This is our mid-module assessment practice, section 1, unit rates. Steve can run 12.5 miles in 1.25 hours. How many miles per hour can he run? Well, this is a division problem. So we have miles per hour. So we have 12.5 divided by 1 1/4. And when we divide this, we get 10 miles per hour. So next it says, write an equation that represents the relationship between the number of miles ran, y, in x hours. So we have y equals 10 x, because 10 is our unit rate. So next, it says a grocery store sells a 6-pack of bottled water for $3.79, and a 9-pack for $4.50, and a 12-pack for $6.89. Which package costs the least per bottle? Well, we have cost per pack. So we have $3.79 divided by 6. Well, that equals 0.6316 repeating, which is 0.63. Then we have $4.50 divided by 9, which is 0.50. And then we have $6.89 divided by 12, and that equals 0.57416, repeating, and that rounds to 0.57 or 57 cents. So when I look at this, this is our best buy. So the $4.50 for a 9-pack is the least. Per bottle. Next, it says the slowest human has ever run is 2/9 miles in 15 minutes. If they run at the same rate, what portion of a mile will they run in 1 hour? Well, the first thing I have to do is I have to change 15 minutes to an hour. To do that, I have to write minutes to change it to hours. Well, there's 60 minutes, right? Minutes. There's 15 minutes and 60 minutes in an hour. So to change that, 15 minutes is 1/4 of an hour. So now we can go ahead and divide. So we have 2/9 divided by 1/4. And this, ladies and gentlemen, as the first question you can do in a calculator, and it becomes 8/9. They can run 8/9 of a mile in 1 hour. So next, it says find the constant of proportionality. And here we have cost over minutes, x over y. So we have to do y over x. So we have 38 over 1,000, which simplifies to 19 over 500. And you do that in your calculator. It will simplify for you, and I showed you that in class. 76 over 2,000 simplifies to 19 over 500. 114 over 3,000 simplifies to 19 over 500. And 152 over 4,000 simplifies to 19 over 500. So our constant of proportionality or our unit rate is 19 over 500. Our next question says, the Smith family traveled a distance of Y miles using X gallons of gas, and it's represented by the equation Y equals 25X. Identify the constant of proportionality, then explain what it represents. Well, remember, our K is our constant of proportionality, so 25 is our constant of proportionality. And again, that unit rate is 25 over 1, and it's miles over gallon, so that means the Smith family can travel 25 miles on 1 gallon of gas. Next it says, last week, Sarah earned $33 for babysitting 3 hours. This week, she earned $55 for babysitting 5 hours. What is the constant of proportionality between the money earned and the number of hours worked? Well, the money earned and the number of hours would be 33 over 3, which is 11, and 55 over 5, which is 11. So the constant of proportionality is 11. Our next question, the proportionality from graphs, says the table below shows the relationship between the number of hours Sue works and the amount of money that he earns. So we have, it says graph the data, determine whether the relationship between the amount earned is proportional to the number of hours. Explain your reasonings. Well, each of these, the hours go up by 3, and the amount earned goes up by 45. So to graph this would be easy enough. So I am going to go by 3s. So I'm going to say 3, 6, and 9. And this is going to be my hours because remember, on top is your X value, on the bottom is your Y. So here is my X value, and this is hours. Remember to always label your graph. And then on the side here, I'm going to put 45. Then I'm going to put 90 and 135. This is going to be, let me write that 135, that looks terrible. This is the amount earned. Okay. So now when I graph this, we have 3 and 45, which is right here. We have 6 and 90 right here. And 9 and 135 right here. So when I look at this, yes, it is proportional. And the reason is it forms a straight line. and goes through the origin. It said, explain what the point 0, 0, and 9 and 135 represent in the context of the problem. Well, 0, 0, okay, means Sue earns $0 for working zero hours. 9 and 135, can't write today. Means Sue earns $135 for working nine hours. Next, it says, using the graph, determine the constant of proportionality. Remember, the constant of proportionality is how much for 1. So if I look at this graph right here, it tells me that, okay? So right here, my y value is 30, my x value is 1. So it's y over x, or 30 miles over 1 hour, or 30 over 1, which is 30. Our next question says, an elevator ascends or goes up at a rate of 750 feet per minute. Is the height to which the elevator ascends proportional to the number of minutes it takes to get there? And explain. Well, if it's 750 feet per minute, 750 feet goes here for 1 minute. So for 2 minutes, it's 1,500. 3 minutes would be 2,250. And for 4 minutes, it would be 3,000 feet. So it wants to know, is it proportional? The answer is yes. And because each number is multiplied by the unit rate. Our next example, and I have to apologize because the table got weird. This is 208. The first number is 208 right here. This is 156. This is 234. This is 168, 120, and 348. So it says Lucas and Brianna read 3 books each last month. The table shows the number of pages in each book and the length of time it took to read the entire book. Which situation represents a proportional relationship between the hours spent reading and the amount of pages read for Lucas and Brianna? So for Lucas, it's 208 divided by 8, and that was 26. Then we had 156 divided by 6, and that was 26. Then we had 234 divided by 9, and that was 26, and that was for Lucas. For Brianna, we had 168 divided by 6, and that was 28. Then we had 120 divided by 4, and that was 30. There we can stop because hers is no longer proportional. So now we can state Lucas, his table is proportional because all the ratios simplify to the same number. Our next question says, when a song is sold by an online music store, the store takes some of the money and the singer gets the rest. The graph below shows how much money a pop singer makes given the total amount of money brought in by one popular online music store from sales of the song. Identify the constant of proportionality between the dollars earned by the pop singer and the dollars brought in by the sale of the song. So if I look at this and I look at this point right here, I have y over x, which means 40 over 200, which equals 0.20, or 20 cents per song. So to write an equation relating the dollars earned by the pop star to the dollars brought in by the sale of the song is y equals 0.20 x. So according to the proportional relationship, how much money did the song bring in from the sale in the first week if the pop star earned $800? Well, if the pop star earned $800, that's our y value. So 800 equals 0.20 x. So I am going to divide both sides by 0.20, or simply divide 800 by 0.20, either way, and we are going to get $4,000. Next, it says describe what the point 00 on the graph represents in the terms of the situation being described in the graph. 00 represents the pop star earned $0 for 0 sales. On the online music store. And I just took what it had on the titles, that's all. It says, which point on the graph represents the amount of money the pop singer gets for $1 in money brought in from the sales in the store? Which point? The point would be 1, 0.20, and that's because that's our unit rate. And that ends our mid-module review.